So welcome to the Eirini update talk. My name is Julz, or also known as Julz, and I'm here with my colleague Nitchev from SAP. And let's start. Okay. So we'll talk about three things today. We'll talk about the Eirini and why it matters. We will talk about the new Eirini, which are the updates that we did since the last update talk at the last summit. And we will talk about the Eiriniverse, which is about making the whole platform more Kubernetes native. So let's start with the Eirini. Come on. So that doesn't work. Oh. All right. So why Eirini? Because humans are lazy. Let's think a bit about this a little bit more. Like technology and machines that we use on daily basis are mostly invented by human laziness. So we used to wash our clothes by hand in the past, and then we invented this nice machine. If it pops up, I would do it by hand. Which is called the washing machine. And all you need to do, you need to put your clothes in there, you press a button, and you get clean clothes. The same appears for dishes, right? You have this dishwashers where you just put your dishes in, you press a button, you get clean dishes. We used to dug holes in the past on constructions and roadworks. Now we have these big diggers that are helping us a lot by doing this work. And we are even too lazy to cook for ourselves. So we have fast food restaurants, which was not the best idea probably, but we love it, right? And we used to go by foot, and at some point we invented cars. And now we're at the point where we even go to self-driven cars, so we don't have to steer ourselves the cars anymore. So what I want to say is that we abstract things away from us, right? So it's really about abstraction. And this laziness and this abstraction is not a bad thing. It is really worth it because it's really time-saving. And if you can't save time, you obviously have more time to focus on other important things, like Netflixing, gaming, making music, like I do. If you make electronic music, by the way, you should check out my SoundCloud. No, serious. We can focus on more important things like real human problems, right? We can spend time on fixing this, and this is what we should do with software. We should focus on our product and solving problems and not on details. So remember back, like last year, who attended the summits and the Eirini talks, we talked about this big elephant in the room, this big scary elephant in the room, which was Kubernetes. This elephant is not scary anymore, but it's still a big elephant. It comes with a lot of context. It comes with deployment, stateful sets, services, Helm, and all that stuff, right? So if we want to deploy our application on top of this platform, Kubernetes, with all that context, so how do we do that? So first you need to create your container, which contains the application. For that you need to write Docker files, you need to know about the Docker CLI, you need to know your runtime and dependencies and how to package them. And then you just got the container, you're not done. You need to get this thing somehow on top of Kubernetes. So for that, you need a registry where you can push your image to, so that Kubernetes can pull it actually. And you need some deployment description to tell Kubernetes, hey, how many instances of the app it should run? Should it be a front-end service, a back-end service? And finally, you need to know about the tooling to interact with Kubernetes, right? So now think about all these steps you will need to do over and over again every time you push an app. And this is not what we want. Now, there was a tweet from Casey Hightower early this year, And he says that Kubernetes is for people building platforms. And if you're a developer building your own platform, like Cloud Foundry, then Kubernetes is for you. So what we want to do again is we don't want to interact with Kubernetes directly because it's too complex. We want to abstract away from it. We want this abstraction, right? Developers want to push their apps easily, and operators with Kubernetes gets their benefit. So Cloud Foundry is this abstraction on top of Kubernetes, right? And Eirini provides this abstraction. And that's why it is important. And with other projects like the CF Quarks projects, you can even get the whole Cloud Foundry control plane on the same cluster, which is really great. So, till the last update, to give you a heads up, we were already able to CF push our application to Kubernetes. We were able to CF scale the application, also to get the logs for your application, right? And to restart an app or just an instance, if you like. And finally, also to get the route for the application actually displayed on the browser or just curl it. So this is all really basic functionality of Cloud Foundry, but this is not what Cloud Foundry is all about. It's not just about pushing an app to the cloud, it's way more. And that's why we didn't stop to work on Eirini. We continued, and Mario will give you the updates.
Right. So during the last few months leading to the summit, we've been making a lot of changes to Eirini to make it more ready for an alpha release. And I'm not going to give you a whole big, boring list of things, but we just picked out a few that we thought were important, starting with security. I think we can all agree that security is hard. And as a platform that makes developers and operators' lives more easy, I think Cloud Foundry should make security easier. So what have we done on Eirini to make that happen? Well, first we secured the connections that Eirini makes and its apps. First, we used TOS for Eirini, and furthermore, we actually require Cloud Controller to have a set of client certificates, so use MTOS to actually talk to Eirini. Next, if you actually remember the last project update, we had a little demo, which was basically, we got the application's Docker URL, image URL, and just using the terminal on my machine, we were able to pull it. But if you think about that, that's terrible, because that's where the user application's images live, and you don't want just anybody pulling them. So what we did is, of course, we used TOS for the Docker registry, so it's secure over the wire, and we actually made the container runtime on Kubernetes authenticate to bit service using a user and password. So let's actually revisit this demo. So what we did was, I already have an app, it's Adora, and what we did was I got the image just by describing the pod. I'm gonna just grep for it. And if I actually copy this again and do a Docker pull, Docker is gonna tell me that I don't have any credentials for that. So what we can do now is actually we have a Docker login. I'm just going to enter the password. And now if we try that again, we can see that it works eventually. So cool. We have a secure-ish registry. We also lock down all the connections that the application's made. So before, you can actually reach other apps and even other pods using the network that Kubernetes uses, which is not something that we want. So we lock down everything. No application can reach another application using just the Kubernetes network, and they can't reach the Kubernetes master either. And for that matter, anything else deployed on that cluster, including the CF control plane. except of course for things like Go router and Doppler, so actual routing and logging works. Of course, they have access to the internet, so if your application happens to be exposed to the internet, another application can of course reach your application. We also secured staging, and let's actually see why staging was insecure in the first place. So what did we do? We first downloaded the application bits from Cloud Controller using a TLS certificate mounted on the container. Next, we used those bits to actually build the droplets, and this is running the user code. Next, we use those droplets, and we use another TLS certificate to upload it back to the Blobster. So why is this insecure? Well, you have the build step run on the same container as the other two steps, and those other two steps require some secrets. So it's way better if we just separate everything out into separate containers. So each container is one single step, which only uses the things that it needs to do its job properly. So I think we all agree that security is hard, and I get it. We all committed a password or two to GitHub before, but it's sometimes not your fault. It's sometimes there's a security vulnerability in one of the packages, one of the dependencies, or even the OS itself. And at that point, you have nothing else you can do except update. And that's why really fast patches are so important. So how do we do them in Eirini? Well, if you're an operator and you already have your installation with Eirini and CF, all you need to do is edit your values file for Helm and do a Helm upgrade. And what that will do is change the annotations on bit service and Eirini, which will cause them to restart. So after Eirini is restarted, all new applications will be annotated with the new root fast version. And when bit service is restarted, it would download the new rootfs and serve any new images or old images also using that. But that's for new apps. But what about the old apps that are already deployed? Well, for them, we have a rootfs patcher job, which basically does the same thing. It updates the annotation on all existing apps, the new rootfs version, causing them to restart. And as they're restarting, they will pull down the new image from bit service, which already has the changes in the new rootfs. So let's actually run through this together. So I already have my deployment again, and I'm going to edit the values file for it. And here we can see the rootfs version. It's version 81. Now we've decided that version 81 has some security vulnerability, and we want to change to version 84. Before I actually do the Helm upgrade, let's see the the annotation on that pod, just to make sure it's 81. It is, and so we have something to compare. I'm going to SH to it, and I'm going to do a SHA-256 sum on this specific file. Now this is the file that actually runs the droplet, and I know between versions it will change the SHA. So for this, this is our SHA. I'm going to copy it over. I'm gonna exit the container, and I'm also gonna echo it, just so we have it. Okay, so we edited our values file. Let's actually do the Helm upgrade, and notice that we're using the same values file. So when Helm does its thing, eventually we're gonna see that bit service and Eirini are restarting. It's going to take a while because bit service needs to download the new rootfs, and that can be up to a gigabyte. But we can also notice while we're waiting that we also have a pod named rootfs patcher version 8400, which is the thing that's actually going to update the application when bit service is done. So after a few seconds, or more than a few seconds, we're going to see bit service restart. Rootfs are big. Any day now. There we go. Okay, so now it's running. We can see that the rootfs patcher is completed and our application is restarted. So now it also needs to pull down the new rootfs, but while it's doing that, we can kubectl describe again for rootfs and see that we have the new version 84. Now that it's restarted, let's go back and do a SHA-256 on lifecycle launch. And this now has a different SHA. And if you don't believe me, I have it in history. So that's how rootfs patching works. All right, just tell us when you're done. So, of course, security is important, but what else should a platform like Cloud Foundry do? 1 second. It should also scale. So we've done some initial scalability tests for Eirini, and I want to share with you some results. So our first scenario was sort of small. It was a Helm deployed Eirini with Cloud Foundry with a cluster of about 10 nodes, and we can push about 200 apps until we saw a few issues, which we'll get into later. Now these are apps that are pushed in batches of sizes of about 10 to 50. So parallel pushed. Next, we had a slightly bigger deployment. It was a Bosch deployed Cloud Foundry this time around, with a Bosch deployed Eirini using the community Bosch release for Eirini. This cluster had about 21 nodes, and it can reach about 1,000 apps before seeing the same problems. And our final scenario was done by a member of the community. It was again a cluster scenario deployed with Helm, with absolutely massive cluster of 250 nodes, and they could push around 2,500 apps in parallel, and then up to about 3,000 pushed one by one. So what issues did we see? Well, first we saw issues with routing. So when your application workloads become greater, routing became a lot slower. So any new routes got delayed. Basically, they got delayed when emitting the routes, so you can reach them. With this, we had also a very small but very annoying bug, which gave a 502 bad gateway whenever you deregister a route, because there's a small gap between actually restarting or killing the application instance and deregistering the routes. And these are things that we fixed for now. We also fixed problems with metrics, which were actually related to the Kubernetes metric server, which needs to be scaled up as your application workloads become greater. And a similar problem we found with logging. So you also need to scale Doppler as well. Of course, this is not everything. We're still working on it, and we still see problems with staging, upgrading the Kubernetes master and the worker nodes, and also bit service being under a lot of pressure during these larger workloads. There is like general unavailability with it. So, of course, this is not everything we've done. You can see the large list of things like CPU quotas, memory and disk limits. If your app goes over the limit, it gets killed. You have custom build pack URLs and all these great features that we've done over the past few months. So that's what we did, but what's actually next for Eirini?
All right, let's talk about the Eirini-verse. So we have Kubernetes, and we know it's a great scheduler. And we also have Cloud Foundry, which is the great platform that provides this awesome user experience, right? And Eirini brought Cloud Foundry as a platform on top of Kubernetes. And now we are working on making the whole platform more native, more Kubernetes native. So let's take a look at the Eirini-verse. So we got more projects looking into making the whole platform more native. So Kapi is working on customer resource definitions to make the API more native. We have the networking team working on Istio integration to make the networking more Kubernetes native. And finally, there is the Eirini X project that is creating a framework to build extensions around Eirini to make basically everything more native, so that the whole platform is becoming more native. Next is, which is a big part for the future, for the next milestone, is to have the migration from Diego to Eirini working seamlessly. There are a lot of discussions going on, so this will be a big part of the future. And another big part that we will work on is so probably most of you know that Eirini today comes with Helm charts that you can deploy together with the SCF on top of Kubernetes, but now we also want to support BOSH for the BOSH environments, of course, so to integrate there smoothly, but also because of the evolution of Cloud Foundry and with the Quarks project and the CF operator, so that you can easily deploy with it. And if you want to try Eirini, go to our GitHub repository, which is Cloud Foundry Incubator /Eirini release. We started to release more frequently, like every week, usually Mondays. And yeah, try it out, deploy it on your Kubernetes cluster. And if you have problems, any questions, or you just want to complain about Eirini or tell us how good it is, we give office hours like every first Monday in the month in a Zoom call. And yeah, feel free to show up and ask questions, chat with us. The Zoom call, you can get it if you go to the Cloud Foundry Slack channel. We always post the Zoom link into the channel before the call actually starts, so feel free to join. And finally, it's not just us working on Eirini, of course. There are many more of us. So here are the names. And if you are up for any questions, we are, of course, around. We are here. Come to us, ask whatever you want to ask. And thank you for showing up.